Hey, thanks. Thanks, Dave. This is sort of, I'm going to let out the Elvis Costello here. What's so special about advanced analytics? We'll push it over on the left. When you think about analytics, and first let me start with what isn't advanced analytics. Sometimes customers will come to us, and advanced analytics is not magic. So it's not going to find your keys under that cushion in your sofa, and it can't find that nugget in the data that no one has ever found before, right? Advanced analytics is taking information from your data from diverse sources and pulling it together to try to figure stuff out. And there are some advantages compared to what you're used to. If you think about alarm limits, I've got a high temperature and I'm going to get an alarm limit. Advanced analytics is looking at the problem from more different data sources, and it's saying, well, at this load, with this product grade, with this age on that compressor, the temperature is higher than it normally is. And so it's going to tell you something's wrong earlier. And that's one of the kind of advantages of advanced analytics, is that earlier knowledge of problems or opportunity. The other thing that's kind of good about it is that if you think about it, I have 10 different compressors and they all have different alarm limits, and I have to figure out what they really should be, and maybe I can trim them a little bit. It takes a lot of time. But if I can use machine learning to learn what's normal operation for these different compressors, and just learn what normal is and then alert on abnormal, then I can build a lot more applications in a day. And so what you can do is more with machine learning. That's sort of the advantage of advanced analytics. The other value proposition, if you look at the traditional strategies for analytics, is that predictive and prescriptive are getting closer to action, right? We're reducing that level of human energy and effort that's required so you get a result. And that gives you more compliance, it gives you more benefit, it gives you more accomplishment of benefits. And so one of our strategies for advanced analytics in the roadmap is doing that idea of making advanced analytics more actionable, closer to the action. And so that is one of our focus. And that's fairly different than what you'll see in the machine learning marketplace in general, right? Rockwell's looking at our history and understanding about taking mathematical models and applying them in manufacturing and saying, all right, let's get closer to that action, right? Model predictive control is that prescriptive, closed-loop analytic that's not only, that has no difference between the model and the activity of delivering the results. So we have experience on both how to deliver predictive and prescriptive analytics, but also reducing that human intervention that's needed to gain a result. George Box, a statistician, said all models are wrong, but some are useful. And so we're trying to give you useful models, and the models don't have to be perfect, they just have to be helpful towards delivering an action, towards delivering a value, and that will be the focus of the advanced analytics applications that we build. The other strategy with advanced analytics that we think is helpful goes along with that line about doing more in the day. We're trying to provide self-service analytics, and the goal of that is that we're making you into data scientists by having software do the heavy lifting in the data science and providing tools that you can use. And that reduces the time that it takes you to explain about data that you understand, business problems you understand, and what the action, how to deploy an action in a plant that you understand better than an expert that you're going to bring in and try to explain it all and convey it and manage that translation. So the whole point of self-service analytics is putting the tools in your arms. Another concept, and I'm going to get into it later in the talk, is the interactive data preparation. And I'll talk about more why that's important, but we do think that interactively managing your data is going to help you understand it and get more value from that data, with the ultimate focus of, how do we gain value in the plant? So the applications that we see people asking about time after time, predictive KPIs, tell me what's causing performance, tell me if my performance is off before I can measure it, give me a prediction of my performance parameter, my quality, and then also give me influences, give me something I can do about it, right? And that aligns with that prescriptive nature where you have to know not only what is it, but also how you affect it. And that is one of the research areas in machine learning today, is that understanding why. Anomaly detection is one of those really, it's almost considered one of the simplest machine learning algorithms where you don't have to have labeled data. You just say, learn normal, just here's good data, tell me when I'm not doing that, and give me an alarm. but as far as driving towards that actionable result, there's a real need to say, don't just tell me something's wrong, tell me why you think something's wrong. Give me some influences or some indicators that become more actionable than just the sky is falling. Predictive maintenance is pretty close to that action. In the ideal case, you tell somebody you have an oil system failure on this rotating equipment, you have a coolant system failure, or there's an alignment problem with this robot. And so that's pretty actionable if you have the data that can develop that. There's some data management issues with developing predictive maintenance. And so we think we have some advantages with that interactive machine learning, that interactive data prep. And the other problem with predictive maintenance is balancing between the perfectly accurate model and something that you can develop quickly. And so that customization is a little bit challenged in the data science that we're trying to address. And we think we have some very nice technologies towards deploying that. Energy optimization is that idea of how do I dispatch this utility equipment, this parallel utility equipment most efficiently, and model predictive control, drive to coordinated peak performance. Our roadmap direction is to make model predictive control simpler. One thing was to push it into the chassis. The other one was the process library objects that we're showing off this week, the accelerator that were released with the 4.0 toolkit. So if you build machine learning, there's a crisp DM, there's this standard industry process towards building machine learning. You start by saying, what's my problem? Gather the data that's relevant, so bring in the data, prepare the data for discovery, identify relationships, and then evaluate the model and interactively say, is this model good? Is this model useful? Can I use it or not? And then there's some interactive back and forth towards getting a useful result that ultimately you're going to deploy and run in a streaming application. Data scientists who've been asked about this, they say 60% of the time to do this work is to prepare the data. And that's where we talk about interactive data prep, right? Data scientists have been surveyed, it's been fairly well published. And so there's a product we're introducing at PSUG and an automation fair called Data Explorer, which allows interactive data prep. You've got this ability to visualize data for information discovery. You've got an ability to clean data, so eliminate outliers, eliminate data that's not relevant to your problem. And do that graphically. There's there's a time merge wizard that's one of the old original Pavilion A patents to flexibly align data from different sources. We've got statistical summaries and statistical interactions that you can look at with histograms and with correlations over time, and also just a rank correlation using time so you can talk about delays and tell me, well, what's the most important variable in this data set that relates to the other variables? And an interactive programless engine to do transformations on your data to clean it out. So the question is, okay, here it is, PSUG members, is this self-service? Can you use this? Is this as easy to use as Excel? Are there gaps between it? But the goal is to give you something that you can use to interact and clean your data and prepare it for machine learning and learn things from your data. Once you have it, then you're going to build a machine learning algorithm, and there are three strategies in the industry towards building machine learning algorithms, and you'll see Rockwell has innovations in all three areas where we're trying to provide them. I don't think that the answer is this is the best answer in every case. There are different strategies, and they're out there for different purposes and different needs. The traditional way to do machine learning is to program, is to pull out Python and R and program an application. And I have that analogy of sort of sometimes you have to take your medicine. It's not the preferred method because it's a lot of work and you need a data scientist. So it's not what anybody would do as their first step, but it solves anything. And sometimes you're going to want to use that latest whiz-bang open source answer that isn't available in a commercial standard product. Automatic machine learning is kind of today's vision. It's like, how do I make that as automatic as possible? Give me a smart data engine that I can throw data at and get a useful answer from. And there's some awesome research and development in this area, and there's some things we're going to ask you to look at PSUG and Automation Fair for automatic machine learning. But there's also a big footprint in the middle, and you don't want to throw out that interactive, where you're going to use your engineering judgment, where you're going to use the knowledge that you have about the data in the plant to get a better answer. And so all of these strategies are going to work for certain applications. So you're going to look for Logix AI, which is the automatic machine learning in chassis. So it has a very attractive footprint for making machine learning as easy as possible. You're going to see Jupyter as a way to program more easily in Dataflow ML, and you're going to see products like Data Explorer, like real-time energy optimization to interact with data that are designed to be very easy to use. So when you look at the different opportunities, there's some confusion that customers come back with. One of the confusions that I wanted to talk about is they say, well, does one replace another? Is there an overlap as far as should I do one before another? And that's the right question. That's an awesome question. What I see is that model predictive control and energy optimization, these are to drive best performance when things are going well. And so their value proposition is, how do I get more from the plant when things are going properly? And as opposed to that, predictive maintenance, anomaly detection are saying avoid problems. Tell me when something's going wrong, right? Don't let me plant shut down. Tell me before something fails. Don't let me run with poorly set up equipment for a very long time. And so their problem benefits and the benefits of model predictive control and energy optimization are completely additive, right? They're contributing to your value proposition, the performance of your plant in independent ways. So, okay, you still have the question, all right, so what do I do first? Or what is more important for my business? The things to look at is first, do I have more failures or do I have more good operations that I want to drive to higher levels of performance? The other thing you want to look at is where do you spend more money? What causes variability between one day and the next? So just try to understand where your opportunities are, and then you can sort of narrow it down. The next level of confusion that I want to address is that I have not been clear about, what can I buy today? What's ready today? And so I want to address that. We talked about, Logix AI released here at Automation Fair. We talked about Data Explorer nearly released. We're showing a beta at PSUG. Real-time optimization nearly released. You can buy these products, and they achieve that self-service analytic answer or approach it today. We are developing anomaly detection and predictive maintenance aggressively. You can buy these today as solutions. You can buy any of these today as solutions from Rockwell. We're on a very aggressive innovation strategy towards realizing that self-service analytic, but they're not all realized today. And like I said, these are more in the future. These bottom three, these are more today. You want products. So the things that you may want as far as self-service analytics are going to be that Logix AI, Data View, which is very much in your hands to build data mashups, Data Explorer to start preparing and looking at your data, and the other opportunities, ask about, talk to it, but probably consider solution pilots if that's the direction that you're going to be wanting to go. So the takeout is, can you use it? Can you leverage Data Explorer? Try it. We've got the hands-on lab that you can play with the tool. We're showing it at Automation Fair. The question is this as easy as Excel? This is a mock-up on the predictive maintenance tool set. You see it kind of follows the strategies of building the workflow for machine learning, get data, clean it up. So this will inherently have the Data Explorer functionality within it and have interactivity between the two. And look at the products that you can see at PSUG and Automation Fair and say, have we realized that self-service analytic? Give us feedback back and tell us if the direction is what we need to be doing.